Effect of the addition of an inert gas on the chemical equilibrium. According to the Le Chatelier's principle, it says that if we have a system at equilibrium and if it is exposed to any kind of a stress, any kind of a change, the equilibrium will react in a way so that it can undo the change, right? The system will shift in a direction so that it can undo the change that was imposed on it. So let's take here an example to understand what will be the effect of an addition of the inert gas on the chemical equilibrium. Let's say we have a PCl5 phosphorus pentachloride, which is actually under equilibrium with a PCl3 and a Cl2, and all of these are the gaseous components here. And you can see in the reactants we have one gaseous molecule and there are two gaseous molecules on the product side. So for this particular example, we have more number of the gaseous moles on the product side than the reactants. Now what is going to happen if you add something which doesn't react with the PCl5, PCl3 or the PCl2? That means the substance that we add actually is an inert, correct? So adding anything any inert gas in a reversible system, how this equilibrium will react? So if you add any kind of an inert gas, a gas which doesn't react with any of the reactant molecules or the product molecules, then two cases may arise. One is that if we add the inert gas at a constant volume, there will be no effect on the state of an equilibrium if you add any inert gas. So there is no effect. But if we add an inert gas at constant pressure, right? We are adding a gas at a constant pressure, not at a constant volume, but now at a constant pressure. Remember, always the equilibrium will react, it will shift in a direction that has more number of the gaseous moles. So we can say equilibrium will shift in a direction that has more number of the gaseous moles, gaseous molecules. So let's try to understand why. Okay, if you write down the chemical equilibrium for this particular gaseous system, we can say you can write the equilibrium constant for this equation. We can say it will be equal to, let's say the Kc here will be equal to the concentration of the PCl3 product and the Cl2 divided by the PCl5 here. Now when you are adding, suppose we have a system here and this is a closed vessel here, and we are adding now a gas in it which is inert, which doesn't react with any of those components, but we don't change the volume. The volume of the container remains constant. So when the volume remains constant, all those these concentration terms, concentrations, the molar concentrations at the equilibrium state will not change. The molar concentration of PCl3, the chlorine for PCl5 doesn't change because we have a constant volume, correct? So when the volume is constant, you can say the molar concentration of each of the component remains the same, that doesn't change. But when you are adding the same thing, same inert gas we are adding it at a constant pressure. So constant pressure means the volume has to increase, right? Means if we have a reaction vessel over here and this is, let's say this is equilibrium over here, okay, we have here the reactants and the products under the equilibrium. Now if you are adding an inert gas at a constant pressure, definitely by adding an inert gas into the reaction mixture, the pressure is going to increase, right? Inside the pressure will increase. Now to keep the pressure constant, the volume has to increase. Okay, so when the volume now increases, you can see by adding inert gas, the pressure inside will definitely increase, but to keep the pressure constant, the volume has to increase. Okay, so when the volume increases, then we can see the molar concentrations of all those terms here will decrease, right? I'll repeat it. The molar concentration of the PCl3, Cl2 and the PCl5, all of those are going to decrease because volume increases here, right? Initially you had a less volume. Now when you are adding an inert gas, the volume has to increase. Okay, when the volume increases, the concentration, molar concentrations of all these terms will decrease. You can see the molar concentration of the PCl5 Cl2 and the PCl5 will decrease, because this concentration is what is the number of the moles divided by the volume, right? And now when those molar concentrations decrease, you can see in this particular example we have more number of the concentration terms in the numerator and only one concentration term in the denominator. That means the change will be more here than here, which means that the equilibrium constant over here will decrease. Correct? When you're adding an inert gas at a constant pressure, volume increases and therefore the molar concentrations decrease here. When the molar concentration decrease, you can see there are two terms in the numerator and one term in the denominator. So that means here will be the more decrease, here will be the less. Correct? So overall you can say that this Kc will decrease. Okay, the equilibrium constant will decrease. Now to keep the equilibrium constant, a constant, okay, that means to increase it, because we know that equilibrium constant, it remains constant as long as we have a temperature constant, right? So to as per the Le Chatelier's principle also, if you are adding an inert gas and therefore addition of inert gas at a constant pressure, volume has to increase and therefore this K will decrease. Now Le Chatelier principle says that when the equilibrium constant decreases here, the equilibrium is going to react in a way so that it can undo the change. Means it will try to increase that value for the K. So how is this possible? How the K can increase? K can increase only when you have more number of the PCl3 and the Cl2 than the PCl5, right? So you should have higher concentration of the PCl3 and the Cl2 and lesser the PCl5. Only then you can increase the K value here. Okay, so that means PCl5, PCl3 and Cl2, this concentration can increase only when the system will shift in the right direction here, okay, towards the right side of this equilibrium. Correct? So we can say here in this case the equilibrium will shift in a forward direction, right, in a forward direction, so that the equilibrium constant K will again increase and comes back to the constant value here. So that means here the dissociation of the PCl5 will increase by adding the inert gas. Okay, so let's take here one more example to understand it more clearly. So we have, let's suppose, a gas, a nitrogen gas and a hydrogen gas under equilibrium with the ammonia. Okay, let's balance it. This is 2 times, this is 3 times, and all of these are the gases systems, and you can see here the total number of the gases moles over here are the 4, and here you got only the 2. Now let's suppose we are adding an inert gas, a gas that doesn't react with the nitrogen, hydrogen or the ammonia. So what's going to happen if I add at constant volume? Okay, no change will occur. But before that, let me write down the equilibrium constant for this equation. So K will be here the concentration of an ammonia power 2 over N2 and H2 power 3, right? So at constant volume, okay, at volume constant, when the volume is constant, you are adding the inert gas at a constant volume, so no change will be there in the volume, so no change in the molar concentrations, right? Volume is constant, the molar concentration of all those terms will remain constant, so there will be no effect, okay, no effect of adding the inert gas at a constant volume. But if you are adding it at a constant pressure, correct, at a constant pressure, so constant pressure means that the volume has to increase. Okay, volume will increase, because when you're adding the inert gas, okay, the pressure inside is going to increase. Now to keep the pressure constant, volume will increase. So that means when the volume increases here, the molar concentration of all those terms will decrease over here, right? So that will decrease, and you can see from this equilibrium constant K, we have more concentration terms from the denominator than the numerator. Okay, so overall effect will be that this is gonna increase here. Okay, it will increase because you have a more decrease here and less decrease here, right? So overall effect will be that it is gonna increase, because you see that in the denominator we have more concentration terms and here we have a lesser concentration terms, so that definitely it will increase the equilibrium constant. Now according to the Le Chatelier principle, equilibrium will react in a way so that it can undo the change, means it will try to decrease this equilibrium constant. So when you are adding an inert gas at a constant pressure, the volume will increase, and therefore this Kc here is going to increase for this particular equation, and therefore the equilibrium will react in a way so that it can decrease this K as per the Le Chatelier's principle. Okay, now the question is how it can decrease this this K value. How K value can decrease? It can only decrease when you have more nitrogen, hydrogen and less ammonia, right? When you have more nitrogen, hydrogen and less ammonia, that means the equilibrium has to shift in the backward direction. So that means in this example, the equilibrium will shift in the backward direction. So now to sum up, you can remember it like this. Addition of an inert gas at a constant volume has no effect on the state of an equilibrium. Okay, it doesn't change, it doesn't alter the equilibrium here. Equilibrium will not move either in the forward direction or in the backward direction if we are adding it at the constant volume. But when you are adding the inert gas at a constant pressure, equilibrium will shift towards the larger number of the gaseous moles. Correct? Equilibrium will shift in a direction that has more number of the gaseous moles. More number of the gaseous moles. Hope you got it. Thanks for watching the video. Bye for now.